Hello, good afternoon to you, and welcome to another very exciting edition of our 1% engineering series. Okay, so today I am going to show you how to program, configure, and link to your HMI a two-state pump, a two-state motor actually, with a latching output, and then with a HOA switch. HOA actually stands for hand, off, and auto, right? So you can take any of those positions. All right, so this is what I want to do today. I will go to module, and then this is the template I want to work with. I will just drag it and drop into an already created area called motors. So this is my mtro-11-HOA_2. I think this is the second one I'm making use of. All right, so I right click on this, and then I go to open with Control Studio. So when I open with Control Studio, I want to delete these tests. These are template tests. Okay, so I'll go here, I right click. I want to show your FV_D, and then this is okay. I want to show FV F in D1, right? I'll show you why I want to see these stuffs. And then lastly, I want to see on the input side also, I want to see SP_D on the input side. Okay, I just added FV_D, F in D1, and then SPD. All right, so if I go to state max of this DC block, DC actually stands for device control. So if I go to the state max, so this is actually the programming part, the program part, what we have actually told this DC block, what we have actually told this DC block to do for us. So in this normal state, in this passive state, the motor is going to be off, and then we're not going to get an off signal, right? We're not getting any signal. We're going to get an off signal. This is just like saying a normally closed or normally open. You know, in a normal state, if it is an NC switch, then it is closed. If it is an NO switch, then it is open, right? In a normal state. So whenever you energize it, right, you tell it use energy, or you want to take it into an action state, right? So the pump or the motor here starts running, and then I receive a feedback of running. All right, so for that feedback of running, I want to work with a discrete input. So this discrete input will tell us, this will be a feedback, right, coming from the pump or from the motor. This, I'll call it running. So whenever the motor is running in the field, I'm going to get a feedback, and that feedback I want to connect to F_in_D1. All right, so F_D_D1, I'm connecting the running feedback. Whenever it comes through, and then it goes to here, right? And then that should just agree with your motor, or your motor actually being started in the field. All right, so what other thing do I want to see here? Nothing for now. So I'll go to save and assign this to this node. Okay, I want to assign this, and then I will hit download. So download this, and then yes, I want to download that. I will close this. Okay, so this is my program. I want to link this program to my HMI, right? So for me to do that, we're already familiar with this process. So I'll go to applications, data view operates configure. Of course, this is where you build your HMI. So for this, it is open now. I want to make use of the same screen I used for the cascade video. So it is, remember, cascade_1. I open it up. If you have not seen that video, you can go ahead and see that video, but it has no link to what we are doing now. I'm just making use of this same screen, right? Of course, you know, you can build and link different programs, modules to a particular screen, right? They don't have to work in the same way. This has different control modules, and then from what I'm going to do now. All right, so I want this, I say Control D. I want it here, and I want to send it to the back, right? So I also want this Control D. I want this somewhere here, and then I think that is okay in the front. Maybe I just need a little adjustment. All right, And then if I go to my dynamo sets, if I go to dynamo sets, I want pumps df. So pumps df, I go downwards, I want this, I want that, so I would close this. Yes, I want to attach it there. And then the next is I just want this, maybe in our subsequent videos we'll link this somewhere else, right? We'll look for where to link this to. All right, so this is send to back. Okay, so we're almost there. I want to animate the color of this pump. Whenever I'll go to the foreground color, I want to animate this foreground color. So I want to use exact match. So whenever it is 0, I want it, that is the pump is not running, I want it to be red. Whenever it is running, it comes with a signal of 1, and then with the true signal, and then I want it to be green. So my data source here, I'm going to link this to lv_d. So I want this is what I'm working on. So go to the DC block, lv_d. So this tells me the state of the motor in the field, whether it is running or stopped. It's 0 for stop and then 1 for running. All right, so that will be for that, for the color. And then for I want to add a faceplate to this, so I go to click. Some of you that saw the video on the Cascade program would be familiar on how to actually attach a faceplate to your program, right, to your elements here. So if I go .v, double click on this open faceplate, and then I locate the module I want to open this faceplate. So it is this module. I say apply now, and OK to that, OK to this, and then OK to this. All right, so I believe we are done. I will just save this and close this, and I will go to the switch to the run mode. So this is the for the screen resolution. I say OK to that. So I silence the horn for some of the alarms I was getting. If you see here, I have warning alarms for critical alarms actually for the past programs which we did. That is fine. I don't want to go there now. So I go to this this cascade_1. That is the display, the picture I want to open, right? So I say open to this. So as you can see from here, right, the color of this is red, showing that the pump is stopped. So if I go back to my program, say no to this. If I go back to my program and I go to the online mode, you will see that currently I'm receiving a 0 signal from the field, meaning it is either in the manual mode, that is the hand, or the off state, right? So that is why I'm getting the value of 0 here. The NOT gate inverts this signal to 1, and then it activates the TRK_in_d, the tracking D, right? And you could see here telling you that you are currently in local mode, right? So but to confirm that, if I click on my faceplate on this pump symbol, excuse me, you could see that it is in the local mode, LO mode, right? So in the local mode, I cannot start this. If I try to start, it tells me device is being operated locally, right? So I cannot start, I cannot stop this. So let's assume that the maintenance guys or the people working on this pump, they are done with it and they want to test run this pump. So what they will do is that they will keep this while it is still in local mode, and then they will switch this to run, and then I should get a running feedback from this digital input module here. So let's say I get a running feedback from there, and then the simulate value here, sorry, firstly let me enable my simulation, and then the simulate value here is going to be true, and then for true here I say good non-cascade. Okay, so if I go back to this, I should see the green color, right? Yes, I can see the green color telling me that they have started the pump in the field, and if they turn off the pump again from the field, I should be able to find this goes to 0, and then I should be able to see this in red. All right, so it is clear that if this is in local mode, they do all the operations right from the field there. But if they switch this to the auto mode, right? So if I get this and I switch this to the auto mode, I enable my simulation. This a simulated process, so these things should come automatically when they switch when they switch to either the auto mode, right? So if I go to simulate value here, I want it 1. Of course, I want it good non-cascade. Remember, I am only simulating. So immediately I do that, this goes off. This goes off because I do not want my tracking D to be active. All right, so but I'm seeing the stats. But what if, because now it's in the auto mode, if you see here, it is in the auto mode, right? So what if I decide it is in the stop, right? Telling me it is stopped. What if I say start? If I say start, my feedback is supposed to return start for me, right? So, but this is what's going to happen here now. If I hit start, so I've started, it is saying starting, it is trying to start, but it should give me an alarm, yes. So I have an alarm, and if I try to acknowledge this, it doesn't go, right? Because that is the current condition you have there. It doesn't go. Okay, so reason being that we did not receive a true signal from our feedback. So what if we now receive this true feedback, right? What if we receive this true feedback? Probably we were not getting it before, and they worked on it, and then when the instrument guys worked on it, or whoever worked on it, and then it is actually bringing the signal for us. This is what is going to happen. Now we have the true signal coming here. If I go back there, I should see it running, and this is confirmed running, and you could see that it is actually also showing you what running. If I stop this, I hit stop, it's telling me I've stopped, but this is going to keep running because the feedback there has not changed to 0, and it's going to give me an alarm shortly. So you see, silence the horn there. So again, if I acknowledge, it is not going to do that. It says stop, confirm it has failed to stop. So if I go back to my program and then I take this to 0, say okay, I've received the no longer receiving running feedback. Now it changes to red, and then it's saying confirm stop, and it has actually stopped. So this is all I want to show you for today. This is how you receive your signal in the control room, and this is actually what happens from the back end and then to the front end. That is to your screen here. I believe this was very clear, but if you have any confusion, just like before, drop me a message through my contact email, and then I'll be more than happy to respond to you. So in the absence of any question on this, and I don't think I need to do any other thing, do I? Probably in our next class, in our next video, I'm going to show you how to actually add interlock to this. But sit down, take care of yourself, and have a wonderful day ahead.